We now return to the practical guide to the universe on the Learning Channel. The original Big Bang theory did not account for clusters of superclusters and holes in the universe. If, after the initial explosion, conditions were the same everywhere, then the matter should be evenly distributed throughout the universe, but it's not. To close the gap between theory and reality, scientists now postulate that the density of matter in the early universe was not uniform. An instant after the Big Bang, it underwent a period of rapid expansion or inflation, which then amplified the non-uniformity, causing the density of matter to vary from place to place. In time, gravity would cause the denser regions of the universe to slow down and contract, and the formation of galaxies would begin.
It is still possible for astronomers to see the earlier stages of galactic creation because as telescopes grow more powerful and look further out into space, they're also looking further back in time. Now, this may sound odd, but let me give you an example.
In 1987, astronomers saw a supernova in one of the nebulae called the Magellanic Clouds. Although the event seemed to be happening in the present, in truth, it had happened over 150,000 years ago.
You see, the Magellanic Cloud is 150,000 light years away, so it takes light that long to get here for us to see it. And the same is true for the Andromeda Galaxy. We see it as it was 2.3 million years ago. Andromeda appears to us younger than it really is. When we look out billions of light years, we see galaxies in their formative stages as they appeared billions of years ago.
A galaxy evolves slowly compared to a human lifetime. What we see is only a snapshot, a single fleeting moment in its existence. But we can learn a lot from a moment. Looking out, we see galaxies in a wide variety of configurations. Edwin Hubble was the first to describe galaxies as ellipticals, spirals, and barred spirals. Later, astronomers added irregulars and peculiars. All these different kinds of galaxies are moving about in space, and sometimes, rarely, they collide.
This is not the most controversial subject, but it's still one where there's a lot of uncertainty, and it's only the last few years we're beginning to think we understand why different galaxies have their shapes. Probably most galaxies have actually started out as spiral galaxies, not too unlike our Milky Way. But then, over billions of years of cosmic time, they collide with other galaxies. There's also evidence, including a lot of good evidence now from the Hubble Space Telescope, that the biggest elliptical galaxies we can see, the giant ellipticals that you often find at the center of a big cluster of galaxies, that these have clearly swallowed lots of other galaxies. And it looks like eventually, if you wait long enough, that most galaxies may end up either swallowing their friends and neighbors or being swallowed, like the fish in the sea.
There is so much space between the stars that they usually pass through each other successfully.
But where some of the larger suns come together, colossal impacts occur, which obliterate the stars and any matter near them. Our own galaxy is not in any such danger of a collision, but even in the cosmos, accidents do happen.
In the far distant future of our universe, however, galactic accidents may become the rule instead of the exception. You see, the universe may one day stop rushing apart and start rushing together again. The instruments that we use to look into deep space have told us much about the murky beginnings of time and space that we call the Big Bang. But they are also beginning to hint at our universe's ultimate end. It turns out that the Big Bang theory that best describes the cosmic architecture that we see today also predicts that the universe contains a certain amount of mass, and that amount of mass exerts just enough gravity to slow down, stop, and eventually reverse the outward expansion of the universe. If this theory turns out to be correct, our universe is one day headed for something called the Big Crunch. In the Big Crunch scenario, the universe will begin to back in on itself. In a reverse of the Big Bang, galaxies will race toward each other, collide, and ultimately compress into nothing. Time and space will come to an end.
The time for such an event would be billions, if not trillions of years in the future. We might wonder if our species will still be in existence to worry about it. Certainly we would be very different than we are today. Perhaps we would have discovered other universes we could flee to, or a way to rejuvenate the one we're in. These are fantastic notions, but we are an inventive race, and if we can learn to control our natures and channel our creative powers to constructive uses, we might be able to survive even the end of the universe.
Next on TLC, we'll join Tom Selleck to visit the homes of the stars, the galaxies, that is, as we tour other planet neighborhoods on the Practical Guide to the Universe.